Hey calculus, let's go through this practice quiz. Number 1. We have the limit as x approaches 2 from the left, and it's equal to infinity. We know if it's equal to infinity that there's going to be a vertical asymptote there. And we know our vertical asymptote is right here. So we know there has to be a vertical asymptote through 2. So that's the first thing we're going to put in. And we're going to label that x is equal to 2. Now, as we come at 2 from the left, our graph has to be going up and up and up and up to positive infinity. So there's a lot of different ways that you can put that in. I'm just going to do this. I'm going to put it going up like this. Okay? Now let's keep going. We're still approaching 2, but now we're approaching 2 from the right. And that also is going up and up and up. So as we come at 2 from the right, our graph has to be going up and up and up and up. And I'm just going to put this in right here. So there you have it. All right, now let's answer the question. Is the graph continuous? All right, whenever you see this, you have to use the definition. So let's first review the definition of continuous. The 3 steps. Let's review the 3 steps. All right, number 1, there has to be a y value. There has to be a point. There has to be a limit. The limit must exist. The limit must exist. And the 3rd step, the y value has to be equal to the limit. So, step 1, is there a y value at x is equal to 2? Well, there's a vertical asymptote there. There is no point here. So we are going to say no, and then we'll say step 1 fails. There is no y value. Okay, now what kind of discontinuity is at x is equal to 2? An asymptote is called an infinite discontinuity. So we say infinite discontinuity. Just put a little abbreviation there. That is an asymptote. Okay, so there's number 1. Number 2, this is pretty similar. We're approaching 2 from the left, and it is equal to infinity. So whenever a limit is equal to infinity, we know that there's a vertical asymptote. And we also know that the vertical asymptote is right there. So right away, put it in. We use a dotted line, and always label it with an equation. A vertical line is always x is equal to, because all the x values are the same. So now, as we come at 2 from the left, we have to be going up, 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 up. So I'm just going to put in a graph, very similar to what we did at number 1. I'm going to go up here. All right, now as we're approaching 2 from the right, now we're approaching negative infinity. So as we come towards this line from over here, we have to be going down. So I'm just going to go like this. There we go. So coming from the left, we're going up and up and up and up. And coming from the right, we're going down and down and down and down. Okay, is the graph continuous? Well, let's go through the steps. Is there a y value here? No, there's no point there because there's a vertical asymptote. So we're going to say no. And just like number 1, we say step 1 fails. F of 2, dne. No y value. And you can put either one of those. Either one of those is acceptable. What kind of discontinuity? Again, that's an infinite discontinuity. Oops, I can't spell infinite. Infinite, I-N. Infinite. Okay, there's number 2. Let's go to number 3. Okay, for number 3, right here, it says f of 4 is equal to negative 2. So that means that when we put 4 in for x, whatever is inside parentheses is the x, out comes negative 2. So this right here gives us a point. If you notice, there's no LIM there. That's not a limit. That is a point. So we plot that point for -2. That is right here. Now we've got our point. The next thing we have as the limit as x approaches 4. So as we get closer and closer to 4 from both sides, the limit has to equal 1. So think about that imaginary line through 4. All right? In fact, you could even kind of put it in with the highlight. That's an imaginary line. We have to be coming towards this line from both sides, and we have to be coming in at 1. There can't be a point at 4, 1 because the point is at 4, -2. So we're going to put a hole there. So it's going to look like this. There's a hole. And now the left and rights have to be coming in there. Okay, so we've got the point, 4, 2. We've got the limit as x approaches 4 coming in at 1. The left is coming in at 1, and the right is coming in at 1. So the limit is up here at 1, the point is down here at -2. Okay, is the graph continuous at x is equal to 4? Let's go through the steps. Is there a y value? Yes, there's a point right here. We have step 1. Is there a limit? Well, there's a good date. The left and the rights are here, and we know there's a limit. So there is a limit, so we have step 2. But we do not have step 3. The limit is not equal to the y value. The y value is at -2. The limit is at 1. So we are going to say no, and we will say that step 3 fails. All right, so f of 4 does not equal the limit as x approaches 4 of our function. What kind of discontinuity as it is at x is equal to 4? Right here, that is a hole. So the fancy name is a removable discontinuity, but you, of course, you can just say hole. All right, number 3 is done. Okay, for number 4, x is approaching 3 from the left, and it's equal to 2. So let's put our imaginary line through x is equal to 3. So here's our imaginary line. Coming towards that line, from the left, we have to be up here at 2. So we have to be coming in right up here at 2. So I'm just going to put in a graph. Coming in at 2. Okay, so as we're coming towards this line at x is equal to 3, we're coming in at a y value of 2. Moving on, as we're approaching 3 from the right, as we're approaching this line from over here, we have to be coming in at 4. So I'm going to put a line coming up here towards 4. Now, this has to be a function. So I can't have a point here and here, because that wouldn't be a function. I can only have one point here. So what you do is you make one of them a hole. It doesn't matter which one. I'm going to make this one a point, and that means I have to make this one a hole. Now I have a function, because when I do my vertical line test, it'll only hit the graph here. So as I'm coming from the left, my y value is coming in at 2. As I'm coming from the right, my y value, my limit, is at 4. So that's how you do that graph. And then, of course, you can get rid of your imaginary line that helped you, because you don't need that. Okay, so is the graph continuous at 3? Well, it is definitely not continuous. Let's go through the definition. Is there a point? Yes, there's a point right here. Is there a limit? Well, this is a bad date. The left and the rights are different, so we do not have step 2. So we say that step 2 fails. The limit as x approaches 3 of our function does not exist. Bad date. Okay, what kind of discontinuity is at 3? This is where there's a step, or it's also called a jump. You can use either one. It is a step or a jump. Okay, calculus, please go through these examples on your own, but this will be on the quiz. Examples like these. Also on the quiz, there will be a section of picking limits of a graph, and there will be a section on solving problems, limit problems algebraically, going through your steps. Can you do direct substitution? Do you have 0 over 0 factoring and canceling? And then limit properties. Make sure you remember the limit of x, okay, and review the limit of a constant. All right, take care, calculus. Let me know how you're doing. Goodbye.